Hello YouTube, this is Crossfire. Welcome to another tutorial on Unity Playmaker series. Today we're gonna cover making a simple bullet and spawning it exactly when we click our left mouse button and making it move, hit objects, and then create raycasts and bullet holes exactly when it touches a surface. So that's exactly what we're gonna do in this tutorial. As you can see, I have created a model for a gun, and actually I'll be uploading it to the link in the description so that you can download this model if you like it. Otherwise you can get a lot of free models on the internet for playing around. So all I've just did is create this gun and place it exactly in front of my camera and create a simple empty object in front of it for the bullet to spawn. That's all which I did. The rest is from the previous tutorial. And I created materials for the bullet and the gun. So let's create a bullet for our gun. Okay, so let's create a cube, a simple small cube. Which would look like a bullet. That's too tiny. So this should do well. Actually, it's a little bit too tiny. Okay, this should do good. I'll just name it bullet and drag this material on it so that we can differentiate what exactly it is. So we have created a simple FSM before for the particle system to be created in front of the gun, and I just changed the gun so the remaining is the same. So now what we'll do is create an object again, but this time it is going to be our bullet, and we should make a prefab before we actually spawn it because it should be within the project folder to be created. So let's add a simple FSM for the bullet, and this should say it should travel in its negative z axis so that it goes relative to the gun. So to fix this, we can just select the player and turn him around to 0, and we'll just drag this in front. So there we have it. So we'll just say translate, which makes the bullet move, and this is going to be z positive, let's say 25 units in the front, which is the positive z axis, in the self space per second and every frame, which would be good. So let's just test it out. Yeah, otherwise we'll just apply it and go to the player, select the bullet which we created at the bullet spawn point, and that's it. So let's hit play and see what exactly we can do. So you can see that the bullet just went in front of us, so it is working perfectly. And to test this, we should just create a basic cube, a wall or something like that for our player to hit. And to this we will add a rigid body to the bullet, and we will just take the translate off because we will use another action called add force, which will be in the positive z-axis. Let's say 200 in the self space, and this shall be force. Okay, let's try that. And this will not be using gravity, so that we can actually make the bullets go straight forward. And the collision detection is a thing that if it is set to discrete, then it is for a normal static object, and it is continuous and continuous dynamic. These are for fast moving objects. So let's set this to continuous for our bullet, and that's it. So let's hit apply and just hit play. And you can see that our bullet is stuck. That is because it is adding force in the z-axis continuously, and you can see that it just flies away to infinity. So it is working. And we will add a quick FSM. In the same FSM we will say collision event. That would say when something collides with the bullet, it would send an event called destroy bullet. And we'll add this, and we will not use the force or anything, so we'll just drag this to the second state and say get collision info contact point, and we'll create a variable. This should say hit point. So this is basically because we need to spawn something at the place where this bullet gets hit. So we'll get the point and we'll create an object, and the next thing we'll do is destroy self. So it does it in the same order which we asked it to do. So, and for this one we will create a simple sprite, I guess. Yeah, so let's select a sprite, and that should be something like this. Yeah, so let's say this is the bullet hole, and I'll just set the color to gray, and I'll just save a prefab for the bullet hole and just delete it. So now you can go back to the bullet and create object, bullet hole, add the spawn point, which is the hit point which we stored, which would be the collision point for our bullet. So let's hit apply, and we'll delete this and hit play. So it also depends upon the tag that you give. So you can see that as I shoot it, it is creating an sprite, and you can see it is aligning itself to the position. So that is basically for creating bullet holes, but this is kind of funny. This bullet hole is too big. We'll just minimize it a little bit so that, ouch, I should have applied it here. So this is a basic application of how to use the collision trigger. So it is working fine. The stuttering for some of the sprites is just because they are in the same position which the cube is. So if you bring it out, you can notice that it won't stutter like this. So a fix for that is simply position and okay, this is for the muzzle flash, this has nothing to do. So we'll go to the bullet, we'll drag the bullet out, and in the Playmaker, in the second state, we'll create the object, add the position, hit point, and we'll be adding a little bit of z-axis so that it doesn't. Okay, I'll show you that in a bit. Add XYZ for a vector 3 variable, hit point, and this shall be 0.1 or 0.01 every frame. No, not every frame, but just add. Just apply it and just play. So now that stuttering should be stopped. Okay, this is being spawned in the inside the cube and not towards the cube. That is the problem. Okay, so it should be negative z instead of positive z. So I'll just go to the second state and say vector z, that will be minus 0.01, and hit apply, and now it should work fine. As you can see, the stuttering has stopped, and you can find good sprites being spawned at where exactly the bullet hits. But there is another thing which would say, you can see that the sprite is being spawned in a rotation which we don't want, so that has to be covered in quaternion, which is a variable for direction from one point to another. So that will be covered in my next tutorial. So this is for the tutorial right now. We have learned muzzle flashes, how to create a bullet, how to add force, and how to move it forward, and a basic muzzle flash concept. And tomorrow I will be doing a tutorial on how to turn the muzzle flash, the bullet holes depending upon the surface which they hit. So they will be looking forward for the normal of this surface. So that will be the next tutorial. Thanks for watching. This is Crossfire signing out.